The third part of the expression series is all about how to have full control over the iterations in a for loop using expressions, how to define what goes in, and what can be used to check against. In almost every project, I come to the point where I need to look if anything is intersecting with anything else, and then of course to decide what to do, whether it is to delete that element, to transform it, or to just mark it. So in my example here, I've set up a case that I've already encountered building my favela HDA that is currently in development. If you are interested, you can go check some of the favela shots on Instagram. For that, we scattered just some curves, and now we want to know which curve is intersecting the other. Let's bring a for each loop to go over every primitive. To check for intersections, you can use the intersect analysis for that. It can detect the intersection with a collision geo in the second input. The default will generate points where the intersection occurs. In our example here, we get 6 points, but if you watch closely, it actually lets our primitive collide with every other primitive that we bring in, including the one we currently loop over. To exclude it from the others, we will use a blast node to delete the one that is currently processed, and we will use expressions for that to get access to the iteration in our for loop, and use that. To get the current iteration, we need a meta import node. This contains some very useful detail attributes like number of iteration, or the iteration itself. We basically want to use that iteration as a primitive number in the blast. If you missed the other vids expressions 1 and 2, where I'm going to explain them in detail, I recommend watching them before you move on. But you should also be fine by just watching this part. Now that we set everything up, let's get access to that attribute. In the group channel of the blast node, let's write detail, the location of the meta node, the name of that node, and the attribute, iteration. End that with a 0. But one thing is still missing here. Every time we use expressions in a group channel, we need to wrap them in backticks. It's that little fella here. It is perfect enough to write just one backtick at the beginning, and you will see if it's working when everything is highlighted like that, enabling us to check it against the other remaining ones. We will end with the correct amount of points, and we'll see immediately where we have intersections. As a little bonus, let's see how we can use that information to actually delete the primitives that are intersecting. To do that, I would use an attribute wrangler and feed the points from the intersect analysis into the second input. We will check if there are any points incoming, and if so, we will delete that specific primitive. So let's make an integer channel where we will use another expression to get the number of points in that intersect node. Normally I would do that directly in Vex, but let's do that with expressions to train ourselves to use them. We then write a little condition where we say if the PTS is bigger than 0, then remove the primitive. Now we only need the expression endpoints and the location and name of our node. Perfect. We just remove the primitives that are intersecting. You can perfectly put these primitives in a group to mark them and use them later on if you need. Next Friday, we will tackle the group by bounding task, where we use a variety of expressions to control our bounding box in the group node. See you next time.